Machine learning, ML, is a subset of artificial intelligence, AI, focused on building applications that learn from data and improve their accuracy over time without being programmed to do so. To grasp the fundamentals of ML, one needs to understand the processes, components, and types associated with this technology. At its core, machine learning involves algorithms that find patterns or insights within data. These algorithms use data as the fuel to train models, simulate human intelligence, and predict outcomes or behaviors based on new data inputs. Key components of machine learning. 1. Data. Raw data is the foundational element of any ML model. It can be structured, organized data typically in databases, or unstructured, like emails, social media posts, etc. Data pre-processing is a critical step here to clean and convert data into an understandable format for the ML model. 2. Model. A model in machine learning is an algorithm that is trained on the data to recognize certain patterns and make predictions or decisions without being explicitly programmed to undertake the task. 3. Algorithm. The algorithm is the specific set of rules and statistical techniques used for pattern recognition and insights generation. Different algorithms are designed for different tasks, like classification, regression, clustering, or dimensionality reduction. 4. Training. This involves feeding the algorithm with data which is processed so that the model can learn and adapt to the input patterns. 5. Evaluation. Once the model is trained, its accuracy and efficiency are evaluated using metric scores. These might include precision, recall, F1 score, etc., depending on the type of problem being solved. 6. Deployment. A model that has been evaluated for its accuracy needs to be deployed in a real-world environment where it can start making predictions on unseen data. Types of machine learning. 1. Supervised learning. In this type, the algorithm is trained using labeled data. Think of this as learning with a teacher. The objective is to understand the underlying patterns and make predictions for the new data. Examples: linear regression, decision trees, random forest, etc. 2. Unsupervised learning. Here, the algorithm is given data without specific outcomes or labels. It searches for patterns or intrinsic structures in the input data. Examples: k-means clustering, hierarchical clustering, PCA, principal component analysis, etc. 3. Semi-supervised learning. It combines both supervised and unsupervised approaches and makes use of both labeled and unlabeled data for training. Example: a member of a classification family can be improved with semi-supervised learning. 4. Reinforcement learning. In this type, the algorithm learns through trial and error, receiving rewards for performing correctly and penalties for incorrect actions. It's akin to training a pet with rewards and corrections. Example: Q-learning and algorithms for autonomous vehicle systems. Applications of machine learning. Machine learning technologies are permeating various industries and applications. In healthcare, ML can be used for predictive analytics or personalized medicine. In finance, it's used for fraud detection and automated trading. In e-commerce, ML powers recommendation engines that enhance user experiences. Other fields like robotics, natural language processing, and computer vision are rapidly advancing thanks to machine learning.